Hello Stonites. Today in this session I want to share to you some of the activities to prove that science is a very interesting subject and it can be understood by performing simple activities. Okay, you don't have to go to the lab. Okay, you can perform even in your house, even in your room. Okay, by selecting some waste material. Okay, so today I can prove you that if you really want to learn science, okay, then you must observe. Okay, you must observe and then you must get experience, and for that you have to work it personally. Okay, by creating, by exploring yourself. Okay, to understand the basic concepts. Okay, the principles that is required when we study. Okay, so whatever you experience in our surrounding, okay, if you experience in our natural resources, then I can prove you, I can tell you that you are learning science in a right way. So today I'm going to, the first activity that I'm going to show you is the attraction between water streams. For that, what I have to tell you is that today we are going to discuss one of the property of a liquid, that is water. You have to take one bottles, you know, like after drinking we always throw it, right? So in that you have to make 3 holes. You may not be visible, but I'm going to show you right now. Then after making 3 holes, then just put water. So I have put water inside it, and then I have closed the bottle. Okay. Now see, even though if I make a hole, the water is not coming out, right? And that is what a student should ask. Why? There is a hole, but water did not fall, or it did not come out from this mineral bottle. But as soon as I open it, you can see that water is coming out. And as soon as if I close it, water does not come out. So the first thing that a science student should know, that how to inquire. Questioning is very important when we learn science. I'll do it again. Right? Now, attraction between water streams. Just say that this is 2 streams. And if I try to connect it, you can see that both of them, they can connect with each other. And if I give a force, they get separated again. If you try to connect, again they get separated. See, to separate them, you need some force. It's not easy to separate these 2 streams. If I connect it, again they join. So, science can be understood in a simple, small bottles, right? Okay, so why? Here you're going to understand the property of water. Water molecule can attract with each other, and that property is called cohesion. Liquid can attract with liquid, like water molecules can attract with water molecule. Okay, it is because of a property called cohesion. And why this water does not comes out even though there is a hole? It's because of the atmospheric pressure. Okay. Now the next activity I'm going to tell you is that it's a very simple activity. I took another bottle. Now I made hole in 3 different places. Okay, 3 different places. Now let me fill the water and check it. Let's observe carefully, okay? Sorry, this is not the one. Sometimes experiments, sometimes faults. So this is the one, okay? Now, I made 3 different holes in 3 areas. In down, can you see in the down? Can you see the middle one? And can you see the topmost one? from this activity, what you can understand? Let's observe carefully. You can see that the down one, the water is falling far away. The second one is more fast. Middle one is more fast. They're flowing too fast. And the third one was slow. The above one was slow. Why is it happening like that? It means that depth of the liquid. The more the depth, the more the water pressure is. So the second activity is liquid pressure increase with depth. मतलब तो किमान नीचे থাকিবो पानी दो इतो अंदर दे pressure to बेसी থাকে. Okay, in Nagamis I am telling you to understand the concept. Okay, so liquid pressure increases with depth. So this is a very simple experiment, okay, that you can perform at home and check it. Okay, just you have to make 3 water bottles, 3 holes in a bottle. The next activity I'm going to show you is, let's observe carefully activity number 3. Activity 3. For that, you have to, the topic is sticking wet paper strip. Wet paper strip. So, you have to take 2 paper, cut this 2 paper, and then just put in a water. And my first question is that, why this paper get wet? Is it because of the paper or is it because of the water? It's because of the water. Okay? And why they get wet? Because of one property called as adhesive property. When we say adhesive, it means that it's because of water. Okay? Adhesive property. Now, let's bring these 2 paper at the end and observe carefully. Try to bring the end. I'll do it again. It needs a careful observation. Let's bring 2 paper at the bottom. As I bring these 2 paper at the bottom, you can see that automatically the above paper get attracted with one another, and that property is cohesion. Okay, the 2 paper, they come together, and why they come together? Because in water, the property of cohesive. These 2 paper strip, when they come closer, there is a force, and that force is called cohesive force. You may study what is cohesive force in class 9 and 10, but you may not understand, you may not observe. And that is the activity showing cohesive force. So the force means what? Push or pull, right? If I push this or if I pull this, there is a force, right? So you can see that 2 paper, they come closer to each other, it means that there is a force. Okay, and it's because of the water that have a cohesive property. The next activity that is very interesting, okay, I want to call one student, okay, please Cynthia, if you can come once, to show activity number 4. Stand there. And that activity is blowing hot and cold. So I want to tell you that our body has warm air and cold air, and that is done especially by our parents when you get accident or when there is a hot objects that harm you, okay, at home. Then what your parents do, right? Shall we do this experiment? Let's keep a palm, okay? Cynthia, I want you to keep your palm front of your mouth, okay? And then first you have to blow. Blow means like that, okay? Do it once. Okay. Now, second time you purse your lips, means okay. In first, when you have done the first activity, when you blow the air, what did you feel? Hot wind or hot air, right? And when you purse the lips, what did you find? Cold air, right? Now, you try to understand here. It means that when there is a warm air in your body. And this warm air, when you blow it, it comes out. But second time, when you purse your lip, pursing of lips, it means that the air which is there, okay, the air which is there get expand. Expand means the air is doing some work, okay, and to do work, what we need? To do work, we need what? Energy, yes or no? The energy to do work, everyone requires energy. That's why we eat food, right? So, the air get expand. It means that the air need energy, okay? To expand, they need energy. And the warm air, there was a warm air, right? That warm is what? Heat, in the form of heat. And this heat is a form of energy again, right? So let's use this heat. From the heat, you're using energy. So if we use energy that was in the form of heat, then what will happen? The air gets cooled. This is a simple activity that you can perform, you can do, okay, at home. And try to understand, if air get expand, what usually happened, okay? This is called the activity, okay, called as the cooling by expansion of gases, okay? Cooling by expansion of gases. Okay, now the next activity that I'm going to show you is, Cynthia, can you hold two paper? Okay, like this, okay? You have to keep at the center like this, nearby to your mouth, and then you have to blow. I want this paper to be separated by blowing like this. Okay, you have to blow and then you have to get separated. Let's see whether you can do it or not. Put it straight, yes. Put above, yes. Let's try it once more. Does it the paper get separated? No. So the question can comes that I took two paper and then you have to blow it. You can see that the paper does not get separated. So the question is why? Okay. The next activity is you have to take a paper. Okay. Take a paper, one paper, and then blow it. Okay. Blow it. Keep it nearby like that, and then blow it. Yes. See, I'm holding like this. Okay. See. It means that when you perform the activity for the first time, you may find difficulties. Okay. That's why I kept one student to show you a demo that don't get discouraged. Keep on trying when you perform the activity. Okay. Once more, Cynthia. Okay. Now, instead of going down, why the paper is going up? This is an example that you can see in the stormy, when there's a storm. some of the house which is not connected or which is not attached with the wall, the tin get blown up, right? Have you seen that? Some houses are blown up, right? So why? From this activity you can able to understand why the tin blows up like this. Okay? Now, these two are experiment or two activities that we're going to discuss, and to understand this is known as your Bernoulli principle, okay? Bernoullis, Bernoulli's principle. So what does the Bernoulli principle says? Flowing air has less pressure. Flowing air has less pressure. Now, let's do it once again. So, see, there is a flow, right? Cynthia, can you see that? So when you blow the air, it means that flowing air has what pressure? Less pressure. Okay? If there's a less pressure means less force. So see, if I blow means this side is a less pressure, but downside there is a normal pressure. Understood? So see, less pressure area, low pressure area. Okay? Once again, less pressure area, high pressure area. Downside there is a normal pressure, and because of that, the normal atmospheric pressure will push the paper upward. Because Bernoulli says that flowing air has less pressure. So the flowing air, see, it has a less pressure, and downside there is a normal pressure, and normal pressure will have more pressure. Okay? And this is the reason that when I have asked Cynthia to do that, see, flow of air. This side will be what? Normal pressure. This side also normal pressure. So, but if I give flowing air, so inside this paper, what happened? Low pressure, less pressure. If less pressure means less force, so normal pressure will, see once again, instead of getting separated, they're coming closer to each other. And this is a principle called your Bernoulli's principle. Okay? Okay, Cynthia, you can do now. Thank you for helping me. Okay? And the next activity that I'm going to show is very simple, but for that you need a straw. You need a straw. Let me perform this experiment and then let's try to understand it, okay? You can see that I took a straw and then I took a TT ball, okay? And then let me blow the air. And I said that flowing air has what pressure? Less pressure. And in this room, what is there? There is a normal atmospheric pressure. Let me perform the activity. You can see that the ball is floating somewhere. Once more. Okay? Why the ball is floating here or somewhere in this point? But as I leave this, ball flows. And you know why it flows? Because of the gravity, right? So the flowing pressure, see, when there was a air, the air somewhere comes here. It means that the flow of air has a less pressure area. In this area there will be a low pressure area, but upward there is a high pressure area. So the low pressure and the high pressure is not allowing the ball to fall, but the ball is floating. So it's a very simple experiment to understand the property of the air, okay? Now, let me perform one more experiment. It is, I want this activity to be a task. You can take a bottle and take a small paper, okay? And then keep in your mouth, nearby to the mouth of this bottle. Took a paper, once again, and then in the mouth of this bottle, put a pepper and let your brother or sister do this experiment. Keep straight and tell your brother and sister to blow the air. Blow it and tell them to blow in such a way that the pepper should go inside. Once again, let me do this activity. Once again, you can see that the pepper is not going inside, rather it's coming out. It's going too far. Why? So science always come up with experience and then questioning why. So this is very challenging. That do you ask question in your classroom? Did you inquire what is happening around you? Or did we just memorize and then just write the principle or the theories in the examination? Did you able to understand the principle, whatever in the book it is written? So it is very challenging. Whatever the theory is given, you must observe it. Okay. So take this. Let me explain this in a very simple way. Okay. The pepper that which I kept here was a small pepper, and what did I say? Flow of air. Flow of air has a less pressure. But do you, in that bottle there is a air or not? Yes, there is a air. So when I blow it, this mouth has a low pressure area. So low pressure area hole ki ho? Force komti ho yate. Normal pressure area, it means that there is more force. So this more force will just push the pepper outward. The pepper will never go inside the bottle. Okay? Take this as an activity, show to your brother and sister. Okay? I want all the students to perform at home. You just need a bottle and a pepper to perform this experiment. Okay? The next activity, I would say that it is a magic. Okay? It's a magic. I will say this. I want Sir Tyrus to come up with the activity once, okay? Please, Sir Tyrus, to show that I'm not doing any, like hide and seek game, but you just need a bell, okay? So, see, if I take the pen, it will fall, right? It will fall because there is a gravity. But take a belt and put in a pen equal weight, and then now this bell is not falling. See, I can just, there is no glue. And I want Sir Tyrus also to get experience. You can put in your hand. Did you experience that the bell is not falling, right? Yeah. And there is no glue, right? If you hold here again, so it does not fall. Why it does not fall? So I will consider that this bell isn't magic. So you can take an example, magic bell, and you can show to your brothers and sister. Okay. Thank you, Sir Tyrus. So this activity is going to prove that everything that you hold at the center, okay, the object will not fall. So what did I do? A trick is, don't tell to anyone that now the pen is fallen. But what did I do is that if you hold anything at the middle, the body is stable. It means that at the center the weight is there. So what did I do was, the belt weight is somewhere here, in this point. But if you see down of this, I made it, the belt and the pen weight in this point. You can do that experiment at home, okay, and then you can show it, okay. But here, the body becomes stable because the center of gravity, it is in this point, okay. Because, so you can see the direction of this point, the belt weight and the pen, it is in this position, okay. That's why the belt did not fall, okay. Now, the last activity that is very simple, and we always keep on telling that if I kept this pen here and I just left, and I return after 2 years. If I kept this pen, or if this bottle, if this bucket, if I left here and left this place and return after 2 years, where do you think this bucket will run away, or it will get disappeared? It will remain there, right? It will remain there until unless someone took away this bucket. If no one took away, then it remains there whole lifetime. It means that a body will be at rest permanently until unless an external force is applied on it, right? So this is what we call Newton's first law, right? Newton's first law. Now today, I'm going to show you one activity. You can take a straw after having those lassi, all those things, we throw it in the roadside. Don't throw this straw, very useful, okay? Connect the two straw. You can see that, see? Straw have, or we have a knot like that, a point, right? This straw, pink straw and green straw, you can connect it, but one straw, you connect like this, at the downside. Don't connect both the end together, okay? The mouth end you connect to the another part. It is what I have done here. Okay? Now, I'm going to give a force. I'm going to give a force. Let's see what happened. Once I give a force, it means the flow of air. Can you see that the straw started moving? Once again. And it was in this direction, clockwise direction, right? Now if I change it, let's see what happened. Can you see that once I change this direction, the clockwise, the action is that side. See? If I change the direction again, what happens? Just see. You can see that it is moving in the clockwise. What Newton's third law said. For every action, there is an opposite and equal reaction, right? When I give a force, means for every action, I'm doing an action. See, I'm doing an action. Once I give action, there's a reaction. Where is the reaction? For every action, there is a opposite reaction, right? The action was in this direction, see? The action was in this direction. But the reaction was opposite or not? Opposite. If I give action in this direction, see? If I give action in this direction, reaction is opposite. So you don't have to buy an expensive equipment to understand basic principle of sciences. This is what Newton's third law said. Okay? So with these 10 activities, I had performed 10 activities with the help of a bottle, with the help of a straw, with the help of a belt, with the help of a pen, with the help of a paper. And I believe that in the days to come, these are 10 experiments which I have selected from the physics portion and a little bit from the chemistry portion. I believe that in the next session, I will try to show you more activities to make you fun and to make you understand the basic principle of sciences. And you will say by your mouth that yes, science is an interesting subject. Thank you for this session.